As I mentioned, there are three major trig ratios that we look at. We just examined the sine ratio, and next we're going to look at the cosine ratio. Let's label the sides again. Again, we have triangle ABC, where C is a right angle, and we'll use B as our reference angle. Whoops. Try that again. So we have right angle C. Across from that is always the hypotenuse. And if we're using reference angle B, across from our reference angle is the opposite side, and beside our reference angle is our adjacent side. So the sine ratio is a comparison of the opposite side to the hypotenuse. The cosine of an angle is a comparison of the adjacent side to the hypotenuse. In short, sometimes we do ADJ for adjacent, HYP we've seen for hypotenuse, or A over H. Cos is adjacent over hypotenuse. Your calculator has the cos button, COS, and we could use it the same way we did for the sine. So again, we'll find now the cos of these angles to 4 decimal places. So on your calculator, make sure you're in degrees. Cos, COS, of 30 is 0.8660. Cos of 45 degrees is 0.7071. Cos of 53 degrees is 0.6018. And cos of 60 degrees is 1/2, 0.5. So again, when we use the angle with a trig ratio, the answer we get on our calculator is the ratio or comparison of sides. The third ratio that we'll be using is the tangent ratio, or tan. When we label our triangle ABC, again, across from the right angle is always the hypotenuse. If we're using B as our reference angle, across from our reference angle is the opposite side. Beside it is the adjacent. We've already compared the opposite side to the hypotenuse with the sine ratio, the adjacent side to the hypotenuse with the cos ratio. So the tan ratio compares the opposite side to the adjacent side. So we can use OPP over ADJ, or simply O over A. So the calculator will tell you this should say tangent ratio for any angle when we use the tan button. So we'll practice that a couple of times. So tan of 30 degrees is 0.5774 when we round. Tan of 45 is 1. Tan of 53 is 1.3270. And tan of 60 degrees is 1.7321 when we round. So these are the basic skills we'll build on next week when we're solving right triangles. Try the practice, pause the video here, see if you can work through these on your own, and then you can restart the video to check your answers. Hopefully you've taken some time to work through these on your own. I'll go through the answers. First, we're going to convert to degrees and minutes when we have, in this case, mixed number for degrees. So degrees and minutes means we want our answer to be whole degrees, whole minutes. I can see here I have 24 whole degrees and 1/3 of a degree. I'm not going to convert that to a rounded decimal of 0.3. This is degrees. I want to do a unit conversion. In order to cancel out degrees, I have degrees on the bottom of my fraction, minutes on the top. There are 60 minutes in 1 degree. Keeping the fraction set up like this, I can go to my calculator and multiply 1 times 60 and divide by the denominator 3. 1 times 60 is just 60, so you can shorten that just by doing 60 divided by 3, and we get 20 minutes. So 1/3 of a degree is 20 minutes. So 24 and 1/3 of a degree is 24 whole degrees and 20 minutes. Same idea for 64 and 3/4 of a degree. I know we have 64 whole degrees. I'm going to convert 3/4 of a degree into minutes the same way. My conversion fraction is 60 minutes in 1 degree. So I can do 3 times 60 divided by 4, and I get 45 minutes. So 3/4 of a degree is 45 minutes. Here we have just a decimal, so 15.3 degrees. If I want whole degrees, there are 15 whole degrees. I can convert the decimal portion, 0.3 degrees, to minutes, setting up my conversion fraction, 60 minutes in 1 degree. And my calculator, I have 0.3 times 60 is 18 minutes. So 15.3 degrees is 15 degrees and 18 minutes. One more, 38.6 degrees. I have 38 whole degrees. Convert the 0.6 degrees to minutes by multiplying by 60 minutes in 1 degree. So 0.6 times 60 is 36 minutes. So 38.6 degrees is 38 degrees and 36 minutes. We can go the other way, converting degrees and minutes to decimal degrees. So I want the whole number of degrees and then the decimal portion. I know here I have 57 whole degrees. I'm converting 36 minutes into degrees. So my conversion fraction has degrees on the top, minutes on the bottom. 1 degree is 60 minutes. So I do 36 divided by 60. 0.6. So that is 0.6 degrees plus that 57 whole degrees is 57.6 degrees. Same for the next example, 97 point. I'm going to figure out decimal portion. If I have 9 minutes, I multiply by 1 degree is 60 minutes. So 9 divided by 60 is 0.15. So 96 degrees 9 minutes is 96.15 degrees. In the next question, you were asked to find the hypotenuse. I'll use H to label that. Adjacent, I'll use A, and opposite side O for each of the reference angles. So always look at the reference angle first. In this triangle, it's angle B. Across from angle B is the opposite side. Across from the 90 degree is always the hypotenuse. So the other side beside our reference angle is the adjacent side. In this case, I'm labeling based on reference angle A, so that's here. Across from the 90 degree is always the hypotenuse. Across from the reference angle is the opposite side. Beside the reference angle is the adjacent side. Here I'm labeling based on angle X. Notice we're never labeling based on our right angle. It's always one of the other two angles. Across from the 90 degree is my hypotenuse. Across from my reference angle X is my opposite side. Beside the reference angle is the adjacent. Here from angle Y, again, across from the 90 degree is the hypotenuse. Across from reference angle Y is the opposite side. Beside reference angle Y is the adjacent side. And finally, you had some calculator practice, rounding these to 3 decimal places. So if I want sine 75, 0.966. Keep working through the same practice with your calculator. So cos 32 is 0.8480 or 0.848. Tan of 12 degrees is 0.213 when we round. Cos 84 is 0.105. Tan 45 is 1. And sine 25 is 0.423. Please get in touch if you need any help with this. Be sure to review this material before we continue on with more right triangle and trigonometry work next week.